Once again, good afternoon all. My name is Henry. I'm representing Micron. I'm looking at the environmental health and safety in Micron. So just a bit of an overview of Micron for all of you that might not be aware. So we are a semiconductor company. We are actually working on the memories and then the DRAMs or NAND flash, the data that basically that you're looking on in your handphones, in your SSD are produced by us, right? We are founded 45 years ago, and we have a company all across the world with 43,000 team members. So we are committed to sustainability, and we have established our goals to achieve a net zero by 2050. And with that as well, we have an interim goal to achieve a 42% reduction in our scope 1 emission by CY30. Other than that, we have other aspiration in terms of our energy, water, and waste, which is conclude all the 4 pillars of sustainability. But today, probably what I really want to focus more is about emission, about our scope 1. And just a give overview of our emission footprints. Probably a lot of you are more familiar that the oil and gas or power sector being a high emission in terms of the greenhouse gases. But in terms of semiconductor, actually our scope 1 is quite big as well. So scope 2 from the electricity about 54%, and typically 45% are coming from scope 1. Out of this, 34% are coming from the process greenhouse gases that's being used in semiconductor processes. So there is a need for us to treat these process greenhouse gases, be it looking at alternatives with near zero global warming potential chemistries, or since this solution currently is not available, we are looking for a way to basically to abate near 100% efficiency. And of course, to reduce or reuse the hard to abate gases. So the challenge that we have is, as we are looking for a way to decarbonize and reduce our emission is, how can we measure it? Okay, that's the first step. If you can measure it, you can improve it. But even the measurement function is something that is currently difficult and currently challenging. So these are typical system in the semiconductor processes for dry etch or CVD, chemical vapor deposition, or some wet processes that is using greenhouse gases. So we have a variety of process greenhouse gases that CF4, NF3, SF6, those are carbon and the fluorine components that's basically required. It goes towards the process chamber or the tool, where it's actually used as a deposition or as a etching. It's going to be decomposed. It goes through a separation, and currently what we are doing is we are putting an abatement unit. This abatement unit is a unit to treat the gases. So when it come out, it can achieve a near zero emission. The issue that we face is currently the abatement unit that we have, the efficiency is probably about 90%. On some of the gases like NOx and all these are even lower. And we want to optimize it. But there is no way to do a active measurement or a live measurement so we can optimize the abatement unit life. We can engage a lab that is a very limited resources to do a measurement, and it was done offline, and you can get the result in like 1 month or 2 months. That might not be sufficient for us to actually improve our abatement. So there's a need for us to improve the data visibility with the smart control, enable real-time processing, and how to enable tuning and then improve our abatement unit. So there are some literatures and there are some standards that actually is available in globally using a FTIR to do this measurement. The concept is a bit simple. They are actually using another system before the abatement and after the abatement using FTIR to capture the spectrums of the gases, and they try to measure the differences to see how efficient is the abatement. Are we actually clearing up 90% of the carbon, 80% of the carbon, 95% of the carbon? Right. But the current system is offline, and the current system that is available is requiring space or basically requiring us to down our production to do the measurement. So obviously there is something that become a challenge, as there are multiple processes, there are many tools that we need to do the measurement. And that's where we come in with this problem statement, and we are seeking for solutions. Basically, if we can have a live measurements, if we can have a system that can meet the EPA and the IPCC guideline in order for us to do a real-time measurement. Targeted sampling of 5% is something that is given globally as well by IPCC in order for us to be able to claim, to be able to have an accurate measurement. But and what is really the benefit to us? And firstly, abatement DRE, or some people call it DG, is required to measure efficiency so we can optimize, because we want to push the boundary. Any company that's actually going for a net zero goal, we want to improve this abatement efficiency, because whatever remainings, if we cannot improve, we need to replace it, or we want to actually replace it with a carbon credit, which is the least preferred option. As much as possible, we want to reduce abatement, or we want to reduce the emission at the source. And not only that, specific to Singapore, there's a carbon tax that is imposed by the NEA. And there is actually a requirement as well by NEA that we need to have this measurement if we want to show that we can do more, that we have actually done something to optimize our abatement. Otherwise, we need to use a standard measurement system or a standard calibration that's coming from the manufacturers, which is typically between 85% to 90% efficiency. And even for those with the lower efficiencies, like below 85%, it need to be reported as zero, which is not reflecting the actual measurement and resulted in a higher emission reported and higher carbon tax. So we are really looking for solutions that can help us to do the measurement effectively, that we can improve our abatement, we can reduce our emission, and eventually it can help to decarbonize. Okay, that's the details that I have. I'm open for any question.
All right. Thank you, Henry. Participants may feel free to add questions to the chat. I'll just start us off. Henry, can you tell us what kind of sampling methods are already being employed by Micron in this process?
The sampling method that currently we employ is using a standard from US, from the EPA standard. We actually engage a lab, and the lab coming from either US, Japan, or Taiwan that actually come in to do the measurement. The method that we use currently is this method on the right hand side, that we are using a FTIR to measure pre and post abatement, and the data will be sent back to the lab for analysis.
All right. And what is the potential improvement that you foresee in this process?
Currently, what we see is we are expecting at least 5% improvement in terms of abatement efficiency. What we see now is most of the abatement system from the manufacturer, they are actually measuring at 90% efficiency to be safe. And there are a certain volumes that is required. But most of our process actually using a lower volume. So we believe with some tuning, we can get it up to 95%.
Okay. And in terms of the desirable aspects of the potential solution that you're looking for, what can solution providers do differently than what is already being done?
We think FTIR system is something that is proven, but the analytics definitely take too long. And the way the data are being pulled, it's also require a down tools. So if there is a solution coming from the systems that combine together with I don't know, some sort of a pods or a measurement system that can be measured live and autonomous analytical, that definitely can help to speed up the analytics and for us to do the improvement.
All right. So what you're saying is the faster you have the data, the better it is.
Yes, correct. Of course, live is the best, but
Okay.
the key thing is to reduce the analytical time and the downtime.
All right. Also, one last question. To what extent is AI already involved in your process? And if it's not, what are the potential applications you see for AI?
Specific to this abatement, the AI currently none. But I
Okay.
mentioned because we are still trying to find what are the right sensors. But we use AI in a lot of other applications. But one of the conditions is always you need to able to measure, and best if you can measure live. So we can have the AI to do the analytics and the live tuning. And so it is really the first step to find what are the right solutions, the right sensors that can provide this data, this analytics, in order for AI to kick in, and then we can see how to optimize it automatically.
All right. Okay. Are there any questions from the other participants in the room? If not, Henry, thank you very much for your presentation. If there are any questions come to us over email, we will definitely raise them to you.
Okay, right. Thank you.
So